1:48 p.m. on 20th of May. Assalamualaikum warahmatullahi wabarakatuh. Login for ITT575 Muhammad Sulaiman, number 2 in the attendance list at 1:48 p.m. on 20th of May.
Assalamualaikum, my name is Siti Khadijah Mutazul KP, number 50 in the list, clock in class ITT575 on Thursday, 20 May 2021 at 1:50 p.m. Thank you.
Clocking in for class ITT575. My name is Muhammad Syamil Haikal bin Satria, number 7 on the list. Today is Thursday, 20 of May, 1:51 p.m. Thank you.
Assalamualaikum, my name is Intan Suhaila binti Muhammad Zaini. Clock in for ITT575, 20 May 2021, 1:52 p.m.
Clock in for ITT575 Nur Fatihah binti Abdul Razak, number 10, 20 May 2021 at 1:51 p.m.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aziz bin Asbiruddin. Clock name English, number 6. Clock in for ITT575. Today is Thursday, 20 May 2021 at 1:53 p.m. Thank you.
Assalamualaikum, I'm Nasifah binti Abu Hassan, number 12. Clock in for ITT575, 20 May 2021, 1:54 p.m. Thank you.
Assalamualaikum, my name is Wadahliana binti Saad. Clock in for ITT575, 20 May 2021 at 1:54 p.m. Number 18 in the list.
My name is Nurul Ain binti Amir, number 13. Clock in for ITT575, 1:55 p.m. 20 May 2021.
Clock in for ITT575. My name is Siti Syara Muhammad Yusof, number 16, on 20 of May 2021 1:59 p.m.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Sarah binti Cik Abdullah. Clock in for ITT575 at 1:59 p.m. Number 17.
Clock in ITT575. My name is Nur Najia binti Rosli, number 11 in the list. Today is Thursday, 20 May 2021 at 2 p.m.
Assalamualaikum, clock in for ITT575. My name is Shoda binti Alwi, number 1. Thursday, 20 May 2021 at 2 p.m.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noah Zamir Azman, number 8 in the list, clocking in for ITT575 at 2:03 p.m. on 20th of May 2021.
Clock in ITT575. My name is Nur Natasha binti Muhammad Amira Srilo. I'm number 14 in the list. Today is 20 of May on Thursday at 2:03 p.m.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi.
Waalaikumsalam.
So alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil sayyidina wal mursalin wa ala alihi wa sahbihi ajma'in. Subhanaka la ilma lana illa ma 'allamtana innaka antal alimul hakim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Wa la hawla wa la quwwata illa billahil 'aliyyil 'azim. Allahumma shalli ala sayyidina Muhammad wa ala alihi wa sahbihi ajma'in. So, alhamdulillah kita dah berjaya habiskan chapter 3. Kita akan masuk ke chapter 4. So, saya share screen. Turn off camera, share screen. Kenapa kamera masih ada? Oh, dua-dua ada. Screen ada, kamera ada. Oh. Okay. Dapat? Tak dapat ya? Ada. Okey. Dah kan? OBS okey, OBS okey. So kita continue. Tu masuk sini. Alright, so chapter 4, wireless personal area network. So sebelum ni chapter 3 kita akhirkan dengan apa? Chapter 3 kita tutup dengan manet kan? Dia punya manet memang ada kaitan dengan personal area network, right? PAN, wireless PAN. Okay, ada 5 subtopik standard for WPAN. Dengar jelas tak? Takut saya terkeluar. Okay kan?
Suara saya sekat-sekat saya.
Suara saya tersekat. Tutup sekejap. Keluar masuk balik ya. Okay, sekarang macam mana suara? Sekat-sekat lagi ke? Kita tak dengar langsung tersekat-sekat. Allahu Akbar. Apa nak jadi hari ni punya internet ah? Kita tukar pakai wire sekejap.
lagi sampai tak? Nah, dah berapa ni? Sekejap, saya keluar masuk balik. Keluar disconnect. Okey, sekarang saya pakai wired lah, tak pakai wireless. Ada apa-apa perbezaan? Sama je.
Okey sikit saya.
Okey sikit.
Okey.
Kalau tak boleh kat saya restart komputer. Pasang kipas. Kalau saya pasang kipas bising tak? Kuat. Bunyi kipas kuat.
Tak dengar bunyi kipas ke?
Okey, cantik tak dengar bunyi kipas. Alright. Content for chapter 4, standard for WPN, principle and IEEE 802.11.50. Yang ni 15 lah standard. 11 wireless LAN lah. Bluetooth wireless LAN. Okey, Bluetooth wireless LAN ada lagi. Ultra wideband and wireless sensor network WSN. Okey, yang ni topik hangat lah WSN. Sehangat Kuala Lumpur lah. Kuala Lumpur Johor kan. Okay, learning outcome. Upon completion of this chapter, students should be able to explore the variation of IEEE 802.15 standards, define and understand technical terms related to WPN, Bluetooth, UWB, ultra wideband, and WSN, wireless sensor network. So students should be able to describe the Bluetooth catenets and piconets, and then explain how Bluetooth works, explain UWB signaling, spectrum and technologies. And also students should be able to describe basic operation and key component of wireless sensor networks. Okay, dalam kurungan kita fokus on Zigbees. Okay, Zigbee. Alright, so kita dah tengok dah wireless LAN, and then wireless dia dalam LAN mana ni? Ini bukan wireless lah. Okay, wireless yang terdapat di selain daripada LAN dan PAN ada dekat WAN. Kita gunakan nampak cellular, WRAN, handoff, mobile, nomadic. Okay, so dia ada kod masing-masing 802.16, 802.20, 21 and 22 ada. Okay, untuk WiMAX kita ada 802.16 kan, WiMAX dalam Metropolitan Area Network ataupun MAN. Okay, so fixed wireless MAN. Untuk wireless LAN kita ada 802.11 ataupun glamour dia Wi-Fi lah. So kita akan pakai dalam LAN ni kita akan ada satu personal area network. Okay, PAN. Okay, kita yang paling banyak kali guna adalah Bluetooth 802.15.1. Ada point 1 nampak untuk Bluetooth. Okay, 802.15 sendiri adalah personal area network. Mana saya punya ni, selalu tunjukkan ni kan. Ini apa ni? Ultra wideband ke? 802.15.3. Cuba cari. Okay, UWB. Okay, and then wireless sensor network kita ada 802.15.5, kita pakai Zigbee. Habis wifi direct kat mana? Okay.
Dekat wifi kot.
Mungkin O2.15 juga kan. Okay, wireless personal area network are used to convey information over short distances among a private intimate group of participant devices. Unlike a wireless local area network, okay, unlike a WLAN, a connection made through a WPN involve little or no infrastructure or direct connectivity to the world outside the link. So kita dah tengok dah slide tu minggu ni kan. Okay, kita tak banyak pakai device ataupun cawang kan. Okay, tak pakai base station, tak pakai kan. So kita tak kurang lah, less infrastructure. Kadang-kadang no infrastructure kan, or direct connectivity to the world outside the link. This allows small, power efficient, inexpensive solution to be implemented for a wide range of devices. So wireless personal area network origins in the body LAN project initiated in the early 1990s. Okay, networking personal devices, sensors, camera, handheld computers, audio devices, etc. with a range of around 5 feet around a soldier. Macam pakai dekat tentera kan. Today networking digital camera to cell phone to PDA. Sekarang ni waktu ditulis ni PDA lah tengah naik. Sekarang kita dah pakai smartphone kan. Okay, to laptop, to printer, to etc. Okay, so kita ada banyak, termasuk RFID kan yang baru kan. Most popular application has free handset to cell phone, free headset to cell phone. Okay, ini banyak lah pakai wireless headset kan, wireless headset. Okay, IEEE 2.15 standard Bluetooth use band available globally for unlicensed user. So tak perlu pakai license. Low power, okay, power pun tak banyak. Okay, power consumption dia kita tak perlu tinggi-tinggi. Bateri pun tak makan kuat kan. So medium data rate dalam 100 second kilobit per second. Okay, nak transfer video saya rasa masih belum okay, tapi audio should be okay lah kan. So Bluetooth, much of WPN focus today is around Bluetooth. Start with Ericsson Bluetooth project in 1998, named after Danish king Harald Bladn, who was found blueberries dengan tooth. Mana tooth? Dia punya gigi dia ke? Radio frequency communication between cell phone over short distance. So Intel, IBM, Nokia, Toshiba, Ericsson form Bluetooth SIG. Dia orang sebelum nak wujudnya Bluetooth ni, nak dapat ketul Bluetooth, dia orang form group dipanggil Special Interest Group. So banyak company yang joint venture untuk wujudkan satu teknologi, nama dia Bluetooth. Okay, pada 1998, in May 1998. Version 1.0. Sekarang version berapa Bluetooth? Version 1.0, our specification came out in late 1999. First version tu. Bluetooth sekarang version berapa? Tak tahu.
5 kot.
Force
5.0.
5.0. Lagi? 6 ada 6. Six. Okay, kebanyakan laptop yang baru-baru semua dah ada Bluetooth 5.0. Cuma device dia kebanyakan yang jual kat pasaran kebanyakan masih lagi Bluetooth 4 lah, Bluetooth 4. Saya cuba cari contoh saya cari adalah beacon. Okay, Bluetooth beacon. Nah, Bluetooth beacon kebanyakan dia masih pakai 4.0 kan. Kalau kamu dapat cari yang base station 4.0, ada tak Bluetooth 5? Nah, okey, nampak kan. Beacon Bluetooth 4.0, Bluetooth BLE 4.0. Nampak? Ada tak? So device apa yang pakai Bluetooth 5.0? Ini adapter dia nak letak dekat komputer kan. Maksudnya kalau laptop lama Bluetooth 3 ke 4 ke, kamu nak pakai Bluetooth 5, boleh beli yang inilah, RM18 je dongle dia. Murah kan?
Murah sekarang sikit.
Murah, tapi device nak connect dia tu tak ada. Ni transmitter. Katakanlah headphone, headset. Headphone. Ada. Headphone Bluetooth 5 29.3, boleh try ni. Headphone ada Bluetooth 5. Ni dah ada. Boleh try. So maksudnya kamu boleh tengok dia punya. Kalau kata sebelum ni kamu dengar dekat headset ni pakai YouTube, dia tak sync suara dengan video kan. Kamu boleh try yang latest 5.0 kan. Beli ni dengan beli adapter dia. Kalau laptop baru tak payahlah, dia memang dia keluar Bluetooth 5 kan. Okay. Tapi kadang-kadang kita tekan ni Shopee ni geram 29 ni dia jual benda lain kan. Harga dia 100 juga. Tu yang geram tu kan. Tapi tengok ni harga lebih.
Kena sabar saya.
Kena banyak sabar lah kan. Macam saya cari ink printer HP kan, dia ada jual paling murah RM29. Tekan-tekan rupanya glossy paper RM29 kan. Option dia bagi option. Bijak juga dia orang tipu Shopee kan. Okay, Bluetooth 5 sekarang. Bluetooth 5. So IEEE 802.15.1 approved in early 2002 is based on Bluetooth. So key feature lower power, pakai 10 micro amp in standby, 50 mega while transmitting. So cheap, $5 per device masa tu kan. Sekarang lagi murah kan. Small 9mm single chips. Chip dia pun kecil kan. So frequency range 2502 until 2580 MHz. Okay, so total dalam ni kita tolak dalam 79 MHz band. So 23 MHz in some country. Ada juga yang dia sikit ya, macam Spain. So data rate 1 megabit per second. Okay. Mula-mula kan version 1 tu dah 1 megabit per second. Okay. So untuk user 720 kilobit per second. Untuk version 2 dah ada 3 megabit per second. Version 5 Bluetooth 5. Ada beritahu dual audio. Okay, Bluetooth 5 dual audio kan lah. Okay, 2 times speed daripada 4.2 kan. Range pun tinggi. Bluetooth has 4 times range daripada 4.2. 2 times speed and 8 times broadcasting message capacity. Okay, so can transfer up to 2 megabit per second. Okay, so boleh pergi dalam 240 meter ataupun 800 kaki kan, 800 feet. Right. Tapi version 3 dia claim 3 megabit per second kan. Apa sudah jadi kan? Saya ingat 20 ke jadi ni, jadi 2 je. Channel bandwidth 1 MHz, range up to 10 meter, can be extended further. So dia pakai RF hopping 1600 times per second ataupun 625 microsecond per hop. Okay, security challenge response authentication 1 to 8 bit encryption key kan. And then TX output power class 20 decibel apa? Meter max. Okay, 0.1 watt until 100 meter kan. So kelas 3 dia macam-macam kan. Dia ada kelas 1, kelas 2, kelas 3. Kelas 3 10 meter. Alright, Bluetooth can connect up to 8 devices simultaneously. Tapi setakat ni kita tak pernah lagi connect banyak-banyak kan. Ada siapa pakai banyak-banyak? Mouse, keyboard, kamera?
Tak ada.
Kan? So 8 tu memadai lah, cukup lah setakat ni kan. Nak buat device apa lah. Speaker boleh ada 8 serentak macam tu. Okay, use a technique called spread spectrum frequency hopping. Randomly chosen frequency within a designated range, changing from one to another on a regular basis. The transmitter change frequency 1600 times every second, meaning that more devices can make full use of a limited slice of the radio spectrum. Since every Bluetooth transmitter use spread spectrum transmitting automatically, it's unlikely that two transmitters will be on the same frequency at the same time. So how Bluetooth operate? When Bluetooth capable devices come within range of one another, an electronic conversation takes place to determine whether they have data to share or whether one need to control the other. Okay, the user doesn't have to press a button or give a command. The electronic conversation happens automatically. Itu yang ada dekat Bluetooth. Once the conversation has occurred, the devices, whether they are part of a computer system or stereo from a network, Bluetooth system create a personal area network. Dah dapat connect tu dah dipanggil satu personal area network kan. Or Piconet, okay, that may fill a room or may encompass no more distance than that between the cell phone on a belt chip and the headset on your head. Once a Piconet is established, the member randomly hop frequency in unison, so they stay in touch with one another and avoid other Piconets that may be operating in the same room. Okay, so dah ada dua sahaja network topology, Piconet dengan Scatternet. Dan letak gambar Pico kan. Scatter siapa? Rumah scatter ada? A Piconet consists of up to 8 Bluetooth enabled devices. When a Piconet is established, one device set the frequency hopping pattern and the other device synchronize their signal to the same pattern. The device that sets the frequency hopping pattern is called the primary device and the other devices are called secondary devices. Each Piconet has a different frequency hopping pattern to differentiate its signal from the signal of other Piconets. Saya punya okey kan? Mic okey kan? Mana satu saya pakai mic? Internal mic ke? Oh, saya pakai dua-dua tapi saya off satu. Kan dengar bunyi dua double. Dah okey kot, tutup dia punya kipas. Okay, macam tadi Piconet consists of up to 8 Bluetooth enabled device. Ada 8, boleh connect 8. Takat ni tak ada lagi 8 kan. So kalau ada dua komputer connect dengan lain-lain, so ada dua Piconet lah, Piconet A dengan Piconet B. So Bluetooth enable electronic device connect and communicate wireless through short range ad hoc networks known as Piconet. So Piconet ni juga kita panggil dia sebagai ad hoc. Piconet are established dynamically and automatically as Bluetooth enable device enter and leave radio proximity. So up to 8 device in one Piconet, one master and 7 slave devices make range 10 meter. So maksudnya 7 sajalah, kan? Satu tu kita punya laptop kita, kan? Lagi 7 adalah device yang lain-lain. Okay, so ad hoc ni no base station lah. Kenapa kita panggil dia ad hoc? Sebab dia tak ada base station. The Piconet Operation ada master. The Piconet master is a device in a Piconet whose clock and device address are used to define the Piconet physical channel characteristic. All other devices in the Piconet are called Piconet slave. At any given time, the data can be transferred between the master and one slave. The master switch rapidly from slave to slave in a round robin fashion. Oh, dia tak boleh serentak. Okay, any device may switch the master slave role at any time. Dia boleh connect saja, maksudnya dia boleh pair lah 8 device serentak, kan? Tapi dia tak boleh operation serentak. Betul tak? Oh, panjang ni. Okay, let's say you have a typical modern living room with typical modern stuff inside. There's an entertainment system with a stereo, DVD player, satellite, TV receiver and a television. There are also cordless telephone and personal computer. Each of these systems use Bluetooth and each form its own Piconet to talk between the main unit and peripheral. So banyaklah Piconet yang connect. Dia ada master dia masing-masing lah, kan? So kamu baca yang lain lah. Ni contoh dia lah, contoh penggunaan dia. Okay, selain daripada Piconet, kita ada Scatternet. Scatternet is formed when 2 or more Piconet are linked by a common Bluetooth enabled device. So Piconet ni kita boleh connect antara satu sama lain. Rupanya boleh, kan? Okay, nama dia Scatternet. Okay, when a device is present in multiple Piconet, it synchronized to the master of each Piconet with which is currently communicating and set the hopping pattern of the Piconet in which it is the master. Okay, mungkin kalau kamu nak try buat sendiri tak boleh. Kalau boleh, siapa yang boleh buat nanti tunjuk kat saya, kan, video. Kalau tak boleh, kamu gunakan simulation yang saya mention hari tu, kan, guna NS2. So kamu boleh buat Scatternet. Cari Scatternet in script untuk NS2. So kamu boleh tengok macam mana dia boleh connectkan Piconet dengan Piconet yang lain. As with Piconet, where multiple Bluetooth devices are able to connect with each other in ad hoc manner, so two can multiple Piconet join together to form a large network known as Scatternet. Bluetooth device must have point-to-multipoint capability in order to engage in Scatternet communication. Several Piconet can be connected to each other through one Scatternet. Furthermore, a single Bluetooth device may participate as slave in several Piconet, but can only be a master in one Piconet. Right? Figure show an example of Scatternet consisting of 3 separate Piconet A, E, siapa ni? P1, P2, P3. Yang C ni connect dengan H dan kebetulan C ni connect dengan A. So C ni sebenarnya dia adalah master kepada H, tapi dia slave kepada A. Right? Example user case demonstrating the need for a clean. Okay. Contoh paling senang dia buat sini, smartphone. Smartphone kita connect dengan laptop, kan? Satu Piconet, kan? Dan smartphone connect dengan laptop, selalu siapa yang jadi master?
Laptop maksudnya je.
Okay, laptop jadi master. And then at the same time, handphone ada device wireless headset. Kan? Yang ni siapa master?
Phone.
Handphone master. So dah ada dua master lah. Ada dua Piconet lah sebenarnya. Alright. Iranian apa? Orang Iran ke?
Orang Iran, sir.
Orang Iran. Use Ethernet to share video. Sampai tahap tu kan. Okay, dia guna P2P. Bluetooth 2.1 features launched in July 2007. The prime innovation, the introduction of secure simple pairing. Sini dah start pairing kan. Okay. So enable device connected together in a Bluetooth Piconet based on a code identification without a yes/no question, query or other verification method. Enable encryption of data exchange between paired device, making the whole data transition more secure. The connection between two Bluetooth device much simpler than before, with no need to enter a PIN, personal identification number. So maksudnya Bluetooth yang awal tu kita kena connect pakai PIN number. Kalau kamu masih ingat lagi, ada certain device macam kat kereta ke, dia minta PIN number kan. So lepas keluar 2.1 dah tak perlu pakai PIN number kan, boleh ignore terus kan. Okay, dia punya teknologi kita pakai 8DPSK. Ni apa ni? Pi bagi 4 pi per 4 DQPSK. PSK ni apa? PSK phase shift keying and Gaussian frequency shift keying, GFSK. Maximum theoretical data transfer rate of 3 megabit per second incorporate as standard inquiry response EIR technology, which create stronger authentication procedure for connecting Bluetooth devices, and then also reduce the power consumption level of the devices, increasing energy efficiency in the process. Bluetooth 3 launched in July 2009, 2 tahun lepas tu kan, aim at increasing the throughput of data exchange over a Bluetooth connection. With the combination IoT.11 link can provide a maximum data transfer rate of 24 megabit per second. Tapi kena combine dengan Wi-Fi lah kan. So initial connection is made using Bluetooth frequency. Kat situ dah ada MAC PHY. Okay, IoT.11 link established between devices handle the rest of the heavy data transport, enabling higher overall transmission speed. A further reduction in the power consumption of Bluetooth devices has been achieved. Okay, Bluetooth radio and baseband parameter, topology up to 7 simultaneous link, modulation Gaussian filtered FSK, radio frequency bandwidth 220 kHz, okay, under 3 decibel, okay, 1 MHz, negative 20 decibel. So RF band, radio frequency band, kita pakai 2.4 GHz ISM frequency band. RF carriers 7923 as reduced option. Carrier spacing around 1 MHz, access method FHSS TDD, frequency hop rate 1600 hop per second. Okay, application ada selain daripada headset, kita ada Bluetooth mouse, Bluetooth keyboard. Okay, cable-less connection of printer, fax, digital camera and video. Banyak printer dah pakai kan. Tak pakai apa ni? Tak pakai Wi-Fi kan, boleh pakai direct, pakai Bluetooth boleh juga. Dial networking, automatic exchange of file, electronic business card, heart rate monitoring, best band kan, wristband kan, banyak wristband. Lagi siapa tahu application dekat mana lagi? Komputer laptop dia tak bagi tahu. Komputer laptop, handset ke laptop, handset ke komputer lagi. Device macam DVD player ke PSP ke ada tak Bluetooth? PSP4 ada pakai Bluetooth tak? PSP lah, PS4. Dia controller pakai apa? Wi-Fi ke? Wi-Fi direct ke? Bluetooth?
Tak sure saya.
Kan? Dia pakai Bluetooth kan? Kamera dah ada kan? Kita punya yang dekat apa nama remote untuk nak ketik kamera tu kan? Nak shoot kamera tu yang selalu pakai kat monopod kan? Dekat basikal dah tak pakai Bluetooth?
Tak sure.
Dekat obat tak sempat obat. Kamu sampai masuk ke kampus, obat dah jahanam semua dah. Dulu obat kalau nak pakai kena on Bluetooth, baru dia unlock Bluetooth dengan GPS kan. Right, dekat obat. Kemudian yang saya pakai tadi, yang saya tunjuk tadi, nama apa saya tunjuk tadi? Beacon. Sini kamu buat assignment pakai Beacon ni lah, dia orang beli. Kemudian saya suruh tu sebelum PKP. Lepas tu bila PKP jadi cacah mabal lah. Nak beli, nak share macam mana kan, nak tunjuk kat kawan macam mana, tak boleh sebab tak duduk dalam kampus. Right, so yang latest banyak pakai ni lah, heart rate monitoring. Heart ni jantung ke hati?
Jantung.
Bukan hati je. Love hati ke jantung?
Hati, liver.
Hati, liver tu organ kan? Tapi itulah orang putih ni pelik sikit kan. Kalau macam gambar jantung dengan gambar hati macam mana? Bentuk jantung dengan bentuk hati lain kan?
Lain je.
Kan? Love tu bentuk jantung kan bentuk hati? Takkan tak pernah tengok bentuk jantung, medulla oblongata apa semua kan?
Medulla oblongata otak saya.
Otak. Lepas tu dia apa?
Aorta.
Okey, tak apa. Nanti balik Google bentuk hati ke bentuk jantung kan? Dah habis. Pergi UWB pula. What is ultra wideband? So UWB based on the transmission of very short pulse with relatively low energy may see increased use in the field of wireless communication in the near future because of the huge bandwidth. UWB wave have a good material penetration capability. So UWB radio signal occupies a bandwidth of more than 500 MHz or fractional bandwidth of larger than 0.2. According to Shannon, macam Shenlong kan, capacity formula, this large bandwidth provide a very high capacity. Those high processing gains can be achieved that allow the access of large number of users to the system. The impulse radio UWB is a carrier-less. For example, baseband radio technology can accordingly in this radio techniques no mixer is needed. Therefore, the implementation of such a system is simple, which means that low-cost transmitter-receiver can be achieved when compared to the conventional radio frequency RF carrier system. So, through the year 1960 until 1990s, the United States military developed the UWB technology that was first used for ground-penetrating radar. Dengar sini baru nampak sikit kan, ada radar kan? UWB. In 1998, the Federal Communication Commission or FCC, kalau kamu tengok dalam elektronik punya part mesti ada FCC number. Okay, so this is a Federal Communication Commission. So dia adalah jaga standard and recognize the significance of UWB technology and initiated the regulatory review process of the technology. Consequently, in February 2002, the FCC report is report appeared in which UWB technology was authorized for the commercial use with different application operating frequency band as well as the transmitted power spectral densities. Because UWB system operate in a very large bandwidth, they need to share the spectrum with other users as well as with the existing communication system, and consequently interference may occur. Besides from the interference from other users, UWB propagation channel will cause disturbances. A wireless technology to quickly transmit very large amount of digital data over a extremely wide frequency spectrum at very low power and over short distance. UWB signal are typically produced by applying an impulse, monocycle or step signal to resonant antenna. Result in that is it use a wide spectrum or bandwidth in frequency domain. Okay, so very low power, 41 dBm, okay, per megahertz. Okay, ni ikut FCC. So very wide bandwidth ada dalam 3.1 until 10.6 gigahertz. Besar bandwidth ya. So why is UWB is so interesting? Why is UWB so interesting? Because 7.5 gigahertz of free spectrum in the US. FCC recently legalized UWB for commercial use. Spectrum allocation overlays existing user, but its allow power where level is very low to minimize interference. So sebab lain very high data rate possible, dalam 500 megabit per second, kan, can be achieved at distance 10 feet under current regulation. Siapa tak nak kan 500. Wifi kamu sekarang berapa? Siapa kata masih 54? Wifi 300 je kan? Kan 300 lah, 2 band 600, macam tu lah kan? Kan, kalau yang lama 54 saja kan? Ini 500. So simple CMOS transistor at very low power, suitable for battery operated devices. Low power is CMOS friendly. More loss radio data rate scale with shorter path width made possible with ever faster CMOS circuit. So semakin lama barang semakin power consumption dia, power yang kita pakai semakin rendah kan. Maksudnya pakai satu bateri boleh tahan lebih lama lah, last longer. Low cost, murah pula kan. Digital radio integration of more component of on a chip ataupun antenna. So pakai yang mana yang ada. Basic of UWB signaling, basic of fractional bandwidth. Saya tengok ni pun nak terang pun susah ni kan. Tengok je lah, kamu tengok je lah dia punya equation dia. Okay, ni graf dia macam ni. So absolute bandwidth kita boleh beritahu dia more than 0.5 gigahertz. So properties that wide bandwidth, low average power spectral density, high temporal resolution, high information transmission capacity. So FCC definition, ultra wideband fractional bandwidth is greater than 0.20 or absolute bandwidth is greater than 500 MHz or more. Kan? So FCC doesn't regulate the method to achieve the ultra wide bandwidth. Ada lagi mesej bunyi. Spektrum dia macam ni. Okay, FCC ruling permit UWB spectrum overlay. Okay, tengok frekuensi dia kan sampai ke 10.6 GHz. Kan daripada 3.1 sampai 10.6 GHz. Tengok beza dengan Bluetooth kan. Kecil je kan. GPS, PCS apa PCS? Tu dia untuk US dah allocate dah kan. Radio spectrum today. You know. Semua digital lah. UWB technology narrowband, wideband, CDMA 5 MHz. So UWB several gigahertz, short electric pulse, sub nanosecond are generated, transmitted, received and processed. So very low duty cycle pulse, no energy content at 0 Hz, occupied bandwidth, information bandwidth. Form a spread spectrum where RF energy is spread over gigahertz of spectrum, so wider than any narrowband system by order of magnitude. Power seen by a narrowband system is a fraction of the total. UWB signal can be designed to look like imperceptible random noise to conventional radios. So there are two competing technology for the UWB wireless communication. Kita panggil dia IR, impulse radio, based on the transmission of very short pulse with relatively low energy, and then multiband or FDM ataupun MB or FDM divide the UWB frequency spectrum to multiple non-overlapping band, and for each band transmission is OFDM. So IR in impulse radio UWB pulse of very short duration, typically in order of sub-nanosecond are transmitted. Because of very narrow pulse, the spectrum of the signal reach several gigahertz of bandwidth. So the impulse of radio UWB is a carrier-less transmission. This technology has a low transmit power, and because of narrowness of the transmitted pulse has a fine time resolution. The implementation of this technique is very simple, as no mixer is required, which means low cost transmitter and receiver. So two variants of our technique. Okay, direct sequence ultra wideband and time hopping ultra wideband. DS UWB, TH UWB. Direct sequence dengan time hopping. Okay, direct sequence UWB, time hopping UWB. Modulation scheme of impulse radio RR-UWB. Data in the RR-UWB communication system can be modulated using different modulation scheme. Dia sebenarnya adalah analog lah kan, kalau ada modulation kan. So kita guna bypass modulation BPM, pulse amplitude modulation PM, and then pulse position modulation PM. Okay, ni ada equation dia. So BPM signal can be expressed as ini, where the pulse shape and TF is the duration of time frame. Untuk PM, okay, PM dia punya encoding data in the amplitude of the pulse. The PM modulated signal can be written as this, kan? AK adalah amplitude of the impulse of the pulse PT, and TF is the frame duration. PPM ini kan, where the data modulation is done by a small shift in the pulse position. K shift, PT is the W pulse, and TF is the frame duration. Okay, MB or FDM. Okay, multiband orthogonal frequency division multiplexing. Combine the FDM technique with the multiband approach. The spectrum is divided into several sub-band with a 10 decibel bandwidth of at least 500 MHz. The information is then interleaved across sub-band and then transmitted through multi-carrier ataupun FDM techniques. The spectrum between 3.1 and 10.6 GHz is divided into 14 band with 528 MHz bandwidth that may be added to or dropped depending upon the interference from or to other system. So figure below present possible band plan where only 13 band are used to avoid interference between UWB and existing 2.11 A signal. So ada berapa saja? 13. Semua ada berapa ni? Semua ada 13 kan? So kita boleh tengok daripada megahertz berapa, daripada frekuensi berapa ke berapa, kan? Ni frekuensi ke 3432, 3960, 448, 50, 16. So ada gap sini kan? Ada 13. The proposed physical layer for UWB support variable data rates up to 480 megabit per second. The desired is 10 meter for 110 megabit per second and 2 meter for 480 megabit per second. Okay, kalau dekat baru dia pergi kelajuan ni kan, 480 megabit per second. Tapi kalau range dalam 10 meter, dia boleh cecah 110 saja kan. The power consumption is in the order of the 100 milliwatt. 10 wireless connectivity for battery operated portable device and wireless with the bit rate. The target bit error rate is equal to 10 to power of negative 5. Okey ke? Tak apalah kalau tak okey.
InsyaAllah okey.
Tengok recording lah. So advantages UWB, ultra wideband, ability to work with low SNR. SNR apa? Tak ingat lah. And then advantage lain adalah low probability of intercept or detection and juga resistant to jamming. Susah nak jam kan ni kan. So application dekat wireless communication system, high resolution radar and sensing and location finding. Location finding guna UWB. Antena penting dalam UWB teknologi, tapi dia macam menyusahkan kan. Antena is a critical part of post shaping filter, monoprobe, electric dipole, magnetic loop. Okay, ada planar, printed circuit, bow tie. Macam bow tie, mana bow tie ada? Ni 3D geometry, discone, equiangular, spiral, Minder line kan, bentuk pelik-pelik ni kan. Contoh sini kita pakai UWB radar, UWB insertion detection. Benda-benda ni mungkin tak pakai. Tiba-tiba kapal selam tu kan, kapal selam, kapal terbang hilang. Mereka nak buat pemetaan kan. Selalu apa yang mereka buat pemetaan lah. Mereka buat cari mana clear, mana tak clear. Kamu tengok tak 370 mh370.gov.my. Tengok website dia, macam mana dia gerakan mencari, adakah masih diteruskan. Itu ada company yang tawarkan diri untuk nak mencari, tak payah bayar. Kalau dah jumpa baru bayar, macam tu kan. Sampai last dia tak dapat jumpa lah. So memang dia pun dah berhenti cari kan. Nak pergi wireless sensor pula. Sensor network definition. A sensor network is a collection of collaborating sensor nodes ataupun ad hoc tiny nodes with sensor capability forming a temporary network without the aid of any central administration or support services. So sensor nodes can collect, process, analyze and disseminate data in order to provide access to information anytime and anywhere. So sensor network features large number of sensor, low energy use, efficient use of the small memory, data aggregation, network self-organization, collaborative signal processing and queuing ability. So back to the history, development started at 1998 when many engineers realized that Wi-Fi and Bluetooth were going to be unsuitable for many applications. Dah ada Wi-Fi, dah ada Bluetooth, tiba-tiba dia rasa tak cukup lagi. Okay, ITT575 standard was completed in May 2003. So introduction to Zigbee is a working group much the same as the Wi-Fi alliance of the WiMAX. Patutlah pun ni dah ada Wi-Fi dia buat WiMAX kan, dah ada Bluetooth dia buat pula Zigbee kan. Alright, so dia nak buat satu lagi for the promotion O2.15.4 standard. Okay, ni contoh Zigbee Alliance wireless control that simply work. So kita akan guna untuk IoT kan. So simpler and less expensive than Bluetooth, lagi murah daripada Bluetooth. Bluetooth tu dah murah, dia lagi murah, dia bajet murah lah kan. Betul ke? Kalau kamu pakai IoT, barang-barang IoT murah mahal.
Bawa royalty murah sikit je.
Okey, murah lagi kan. So betul lah dia cakap. Main objective is of installation, reliable data transfer, short range operation, extremely low cost. Dia tulis extremely, nampak? Bukan low cost saja, extremely low cost. Gila-gila murah kan. Okey, 10 boleh beli dengan 10 sen. Murah lah. Satu sen lah. Reasonable battery life. Barang elektronik memang murah sebenarnya kan. Kan dia punya, kalau perintang tu, kalau beli perintang tu harga satu perintang berapa?
Berapa sen?
Perintang kita panggil apa? Perintang.
Register.
Perintang Shopee. Panggil apa perintang? Ni.
Register.
Resistor. Kata murah ni 1,000. Inilah 0.41 sen batu. Mana yang murahnya? Oh, patutlah pun. Tengoklah kuantiti dia berapa. 10 kan? 10 ringgit satu, 10 sen lah. 10K ni apa?
Ohm juga.
Ohm. Inilah komponen yang paling resist sekali kan. Resistor 10 dia jual 10. Ni jual 50. Ni baru saya nampak murah sikit kan. 50. Berapa satu? 50 RM1. Satu jatuh berapa? Murah lah kan, murah lah. 50 RM1. Barang apa lagi yang kamu boleh beli RM50 sekarang? Mask dapat RM50. Face mask
dapat.
air apa tu RM50? 50 liter
50 ml
50 ml kan. Dah ni 50 pieces, maksudnya 50 botol RM1 ada. Air apa tu? Tak ada kan. Air kosong pun tak dapat kan. Dia murah sungguh kan. 50 pieces RM1 je. Satu jatuh berapa ringgit? Satu jatuh berapa? 5-10 sen. Betul? 5-10 sen kan? 5-10 sen, satu 2 sen. 2 sen lah. Satu 2 sen lah. 2 sen. Fotokopi sekarang pun tak dapat dah 2 sen kan. Dulu dapat lagi kan. Kertas lah. Kertas murah lah kan. Kertas murah. Kertas 800 lah. 800 apa? Kertas A4 apa? Kertas pun mahal lah. A4 double A. Cuma ambil mahal. Ni kilogram. Gram ada 500 sheet. 511 ringgit. Kertas mahal lagi. Kan? Mahal RM1 10 sen. Nak habis dah rupanya. Okey, kita teruskan lagi baru pukul 3. Okey ya? Semua okey ya? Sikit je ni.
Okey, insyaAllah.
Okey, Zigbee ya. Okay, data rate, raw data rate will be high enough, maximum of 250 kilobit per second to satisfy a set of simple needs such as interactive toys, but it also scalable down to the needs of sensor and automation needs 220 kilobit per second or below using wireless communication. Kan? So main objektif dia selain daripada extremely low cost, so reasonable battery life. Okay, dah lah paling murah, short range saja. Tapi dia tak target jauh-jauh kan, dia short range saja. Kan? Macam Bluetooth tadi, semakin lama semakin besar kan, makin jauh kan. Tapi kalau nak besar-besar, baik pergi wifi terus kan. Okay, ni betul dia dalam short range saja. Tak jauh lah. Okay, so dan kita boleh jimatkan bateri and then maintain a simple and flexible protocol. Tak guna protokol yang susah-susah kan. What is Zigbee? Technological standard created for control and sensor network based on IEEE 802.15.4 standard created by Zigbee Alliance, named for erratic zigzagging pattern of bees between flowers. Okay, symbolize communication between nodes in a mesh network. Oh, dia macam zigzag. Okay, dan zigzag dan bee maksudnya mungkin lebah punya sarang kot ataupun madu kan. Kan dia bentuk pattern macam dia punya note dia lah itu kan, macam selular pakai kan. Okay, honey kan. So Zigbee is a standard for mesh networking built on IEEE 802.15.4 standard. Ulang balik, reliability through mesh connectivity, designed for low power application, very long battery life, low data rate 20 to 2050 kilobit per second depending on band, and very secure. Oh, ada security pula, ada pakai AES-128 encryption available, self configuration, allow ad hoc network and ease of installation and configuration. And okay, kita boleh tengok perbandingan dengan Bluetooth dan Wi-Fi. So dia boleh, bandwidth dia kecil saja, 250 kilobit per second, 4 kali ganda kan. Wi-Fi tinggi kan. Ni bukan bandwidth, dia punya speed dia kan. Tapi tu bandwidth. Kalau bandwidth letaklah dalam hertz kan, baru senang kita nak compare kan. Bandwidth besar pakai hertz kan, frekuensi. Power consumption, nampak power dia pakai 30 lah, tapi Bluetooth pun tak jauh beza lah, 40 kan. Okay. Oh, standby dia ada 356 micro, macam tak pakai je. Standby 0.2 mili kan. Protokol 34 kilobyte per 14 kilobyte, long battery life, low cost, remote control, battery operated product and sensor. Tengok dia pakai. Pakai dekat ni. Alarm kita pakai ni ke? Zigbee ke? Tak pasang rupanya. Alarm kereta kunci kan? Ke alarm lain ni? Lampu and then IoT. Ni apa ni? Nak control apa ni? Tak cerita pun. Oh, kebanyakan pakai IoT lah kan. Fire and smoke sensor, entertainment control, programmer lighting, air conditioning, moisture sensing and control, sprinkler, actual dekat farm kan. Dekat farm memang baguslah, dekat ladang, sebab kita tak ada wifi, tak ada selular, semua tak ada kan. Okay, so ni contoh smart house project, bacalah. Ni punya contoh-contoh dekat dia pakaian. Okay, lagi semua sama home automation. So standard dah, kita pergi standard ni. Application dah kamu baca. Okay, So IEEE 2.15.4 define only the PHY. PHY ni adalah physical layer and the MAC media access controller. Okay. So dia dekat tengah-tengah lah kan. Okay, Zigbee Alliance. Ni dia punya protokol dia kan. Framework, application framework dia, dan 2.15.4 define dekat physical layer. So maksudnya dia sebelum naik ke atas lah, connection dia tak ada lah minta IP apa, tak ada lah kan. Okay. So dia ada MAC tak? Dia ada MAC address tak? Mestilah ada kan. Dia pun ada MAC address juga, cuma dia tak ada macam Wi-Fi lah. Dia sama macam Bluetooth. Bluetooth ada IP address tak? Tak ada kan. Okay, packet generation, packet reception, data transmission, power management dekat PHY, physical layer. Okay, so dia ada dua lah, physical dengan MAC. Atasnya Zigbee application. Table untuk frequency band and data rate. Okay, saya cepatkan lagi. Zigbee in the wireless world, band, topology, data rate, power consumption range, security size, band dia 868. Okay, 902.928 MHz, 2.4 MHz. Ada juga topologi pakai ad hoc, star, point to point ataupun mesh. Data rate 20-40 kilobit per second and 250 kilobit per second. Dia tak perlu laju-laju lah. Nak hantar signal, kebanyakan dia hantar signal je banyak kan. Dia tak perlu hantar audio ke video ke. Power consumption very low, range 10 to 100 meters, security very high, AS 1 to 8 level encryption, size up to 64 kilo nodes in a single logical network. Nama pun wireless sensor kan, nak cari sensor je. Okay, untuk physical layer overview, operating frequency band. So untuk Zigbee ni dia ada channel 0, and then channel 1 until 10, and then channel 2.4 GHz dia pakai channel 11 to channel 26. Okay, gap ada 5 MHz between channel. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, satu ni channel 0, channel 1 sampai 10. Ni 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Dia selepas ni. Okay, kita panggil dia channel 11 to 26. So ada berapa channel ni? 15 kan? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Ada 16. Daripada channel 11 sampai channel 26. Packet structure, bentuk packet dia macam ni. Ada preamble, start of packet delimiter, physical header, physical service, data, unit PSDU. Size 32 bit untuk preamble, start of packet delimiter 8 bits, physical header 8 bits, and PSDU dalam 1016 bits lah. Octet dengan bits boleh kira kan. 8 kan, 88. So maksudnya macam RAM lah, 888 bit. Tu pentingnya kuasa 8 tu. Okay, yang kedua dekat Mac pula, channel acquisition, contention management, NIC address and error collection dekat Mac. Okay, message propagation in Zigbee. The way that a message propagate through a Zigbee network depends on the network topology. However, in all topology, the message usually needs to pass through one or more intermediate nodes before reaching its final destination. The message therefore contains two destination address of the final destination, address of the node which is the next hop. The way these address are used in message propagation depend on the network topology. Okay, message propagation in star topology. All messages are routed via the coordinator. Both address are needed and the next hop address is that of the coordinator. Okay, so network example, home automation, PC peripheral, personal healthcare. Okay, untuk ni pula kita ada PAN coordinator. Example network topology in the area of home atau living room control set-top box is acting as the master with a remote TV, DVD, lamp or curtain animated on the network. This has no functionality since the slave can only talk to the master. What the consumer actually want is to be able to control TV, DVD, lamp and curtains using the remote. In this case, there need to be some virtual peer-to-peer link between the remote and the other devices on the network. The mechanism of creating this link is known as a pairing. A message routed up the tree until it reaches a node that can route it back down to the tree to the destination hop. Both addresses are needed and the initial next hop address is the part of the parent of the sending node. The parent node then resend the message to the next relevant node. If this is the target node itself, the final destination address is used. Okay, kita tengok ni semua full function device into communication flow. The last step is then repeated and message propagation continued in this way until the target node is reached. Okay, dalam mesh topology pula, in this case the propagation path depend on whether the target node is range. If the target node is in range, only the final destination address is used. If the target node is not in range, the initial next hop address is that of the first node in the route to the final destination. The message propagation continues in this way until the target node is reached. Ada combined topology cluster star, kita panggil cluster star. For example, cluster node exists between room of a hotel and each room has a star network for control. So Zigbee device class ada full function device FFD, reduced function device RFD, bukan RFID ya, RFD. Okay, available in FFD, available in any topology capable of becoming network coordinator, talks to any other device, typically continuously active, looking for stimuli. Okay, RFD limited to only star topologies, cannot become a network coordinator, communicates only to a network coordinator, simple implementation, efficient and low power. So coordinator pula, Zigbee coordinator transmit network beacons, set up a network, manage network nodes, store network node information, route message between pair nodes, receive constantly a full function device ataupun FFD. Contoh sini kan. Tadi coordinator, sekarang kita ada router ZR. Routes message does not own network, tak ada network, scan to find the network to join, give a block address to assign, a full function device atau FFD could also have I/O capability. Walaupun dia tak ada own network tapi dia ada I/O capability. And last kita panggil dia end device. End device atau ZED. Communicates with a single device, does not own a start network, scan to find network to join, can be FFD, RFD, so usually battery power. So kat ZED ni lah yang letak bateri. Kan, rotor end device, coordinator kan. End device. Dekat MAC layer pula kan, overview. So 4 type of MAC frame: data frame, beacon frame, acknowledgement frame and MAC command frame. Traffic type: data is periodic, application defined rate. For example, sensor data is intermittent, application external stimulus defined rate, optimum power saving. For example, light switch. Data is repetitive, device get guaranteed time slot. Okay, repetitive. Data transfer model: coordinator to device. Data transfer from coordinator to device in a beacon enabled network. The coordinator indicates in the beacon that the data is pending. Device periodically listen to the beacon and transmit a MAC command request using slot CSMA CA if necessary. Okay, data transfer from device to coordinator in a non-beacon enabled network pula. A device transmits a MAC command request using unslot CSMACA. If the coordinator has its pending data, the coordinator transmits data frame using unslotted CSMACA. Otherwise, coordinator transmits a data frame with zero length payload. Superframe. It is a time duration between two consecutive beacons. The structure of the superframe is determined by the coordinator. So beacons are used for starting superframe, synchronizing with associated device, announcing the existence of a PAN, personal area network, informing pending data in coordinator. So Zigbee routing use AODV, ad hoc on demand distance vector. AODV, ad hoc on demand distance vector. So capable of both uni atau multicast routing. The active protocol establish route to destination on demand, not actively like IP routing. On of the usage of the particular path, network is silent until a connection is needed. When a link fails, a routing error is passed back to transmitting node and the process repeats. Route discovery. The Zigbee stack network layer support a route discovery facility in which a mesh network can be requested to find the best available route to the destination. When sending a message, route discovery is initiated when requested by a data transmission request. So ada route discovery option. There are 3 options related to route discovery for a mesh network. Suppress route discovery, enable route discovery, and force route discovery. Suppress route discovery, the message is routed along the tree. Enable route discovery, the message is routed along an already discovered mesh route. If one exists, otherwise the router initiate a route discovery. Once this is complete, the message will send along the calculated route. If the router does not have the capacity to store the new route, it will direct the message along the tree. Last, force route discovery. If the router has the route capacity, it will initiate a route discovery even if a known route already exists. Once this is complete, the message will be sent along the calculated route. If the router does not have the route capacity, it will route the message along the tree. Usage option should be restricted as it generated a lot of network traffic. Route discovery mechanism. The mechanism for route discovery between two end devices involve the following step. First step, a route discovery broadcast is sent by the parent router on the second end device. This broadcast contains the network address of the destination end device. Second, router eventually receive the broadcast, one of which is the parent of the destination end device. The parent router of the destination node sends back a reply address to the parent router of the source. As the reply travels back through the network, the hop count and a signal quality measure for each hop are recorded. Each router in the past can build a routing table entry containing the best paths to the destination end device. Eventually, each router in the past will have a routing table entry and the route from source to destination end device is established. Note that the corresponding route from destination to source is not known. The route discovered is unidirectional. So ni table untuk Zigbee, physical and MAC layer. Topology ad hoc, central plant coordinator, RF band 2.4 GHz, ISM frequency band. RF channel ada 16 channel with 5 MHz spreading. Kita pakai DSSS dengan 22 chip and per 4 bits. Chip rate 2 mega chip per second. Modulation using offset QPSK. Access method using CSMACA or slotted CSMACA. So ni target dia. Building automation, personal healthcare, industry control, residential light, commercial control, smart home lah kan. PC peripheral and consumer electronic, TC, TV ke, VCR ke, RF remote, so dia akan pakai kan. User of sensor network kita pakai dekat environmental observation, water air pollution detection, forest fire detection. Ada tentu kan, nak letak dekat hutan kan nak kena maintain power nak cari mana kan, network nak cari mana. So kita buat network sendiri ataupun sensor network ni, ataupun animal habitat monitoring. Pernah tengok tak dekat YouTube dia orang rakam video animal kan? Okay, so untuk environmental observation. And second, military monitoring. Ni yang tujuan asal dia kan. Battlefield surveillance, vehicle traffic monitoring, tracking the position of the enemy, tracking. Building monitoring, okay, dalam building. Monitoring climate change, vibration, atau dan last kita pakai dekat healthcare, be implemented in the human body to monitor medical problem. Macam kita dah masukkan dalam vaksin kan. So kita masukkan wireless sensor network dalam vaksin. Kau perasan tak? Tak perasan? Tak ada pun kan. Tu isu apa ya? Isu menakut-nakut orang-orang supaya jangan ambil vaksin kan. Konon-kononnya ada benda ni lah. Ada Zigbee lah dalam tu kan. Sebab Zigbee kan tak boleh pakai apa nama bateri power kan. Letak bateri kecil tu pun jadi. Bateri paling kecil kamu pernah tengok besar mana? Bateri bulat kecil tu yang duduk dekat mainan adik kamu tu kan. Perasan?
Bateri jam.
Oh, bateri jam lagi kecil. Betul ingat. Bateri jam lagi kecil. Jam tangan kan? Jam tangan ke jam panggang bunga? Jam tangan lah.
Jam tangan saya.
Jam tangan lah. Lagi kecil daripada yang mainan tu kan. Mainan tu besar sikit. Betul, bateri jam lagi kecil. Boleh pakai Zigbee tu. Tak perasan lah. Bubuh dalam vaksin mana orang perasan kan? Kecil tu. Okay, semua agenda Yahudi dia berkata kan. Agenda konspirasi. Orang yang tak belajar ni pun takut. Macam mana nak masuk benda ni kan? Sensor nodes ada MICA2 atau most popular research platform for at the time. Masa tu lah ada orang suka pakai benda ni. Okay, boleh cari. Okay, apa dia boleh buat. Itu je. Okay, dia bagi yang contoh yang tu. Kita cari contoh lain lah. Zigbee Shopee. Sini pun ada kan Zigbee. Zigbee. Ni pakai apa ni? Smart lock. Okay, pakai smart lock apa? Remote control gateway RM60. Smart home switch Zigbee, pakai Zigbee. So Zigbee ni boleh pakai kat mana? Motion sensor ceiling ada nampak? Light wall. Switch plus, maksud switch ni dah ada Zigbee, tak perlu pening-pening kan nak connect. Boleh try ni. Kamu petik switch ni dah boleh connect dengan macam-macam kan. Janji lampu ada Zigbee, fan, kamera night pakai Zigbee nampak. Okay. Dekat Arduino boleh letak Zigbee. Arduino Zigbee ada. Nampak? Oh lah, mahalnya. Kata dia yang paling murah kan.
Lagi murah Bluetooth saya.
Lagi murah Bluetooth.
Bluetooth Arduino lagi murah daripada Zigbee Arduino.
Oh. SB apa pula? Pakai Zigbee lah SB. Ke benda baru yang tak ada dalam kita punya ni. Pakai Zigbee. Nama dia SB. Company ni nama SB lah kan. Okay, so dia pakai Zigbee. So ada sini. Boleh pakai. Dia pakai. Kena pakai kat Arduino. Raspberry Pi. Try ni. Boleh lah projek IoT. Macam mana kamu tak ada duit nak pakai lah, dah minggu 7 tak sempat buat projek kamu tu je lah kan. Dan kita dah belajar banyak lah kan. Right. So any question? Ataupun soalan pasal lab pun saya tak buat lagi. Hopefully saya buat dalam weekend ni lah. Esok tak ada kelas. Petang ni saya ada, petang ni kelas kamu lah. Tak ada. So tak ada, kita tangguh dengan tasbih kifarah dan suratul wal'as. Lepas tu clock out lah. Boleh ya?
Okay, baik sir.
Okay, so subhanakallahumma bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asri innal insana lafi khusr illa alladhina amanu wa 'amilus solihati wa tawassaw bil haqq wa tawassaw bis sabr. Shadaqallahu azim. Assalamualaikum.
Thank you sir.
Sama-sama.
Thank you sir.
Sama-sama.